So, in this lesson, we are going to discuss sampling without replacement and how to find probabilities when doing so. We are going to start with a jar that contains 20 blue marbles and 12 red marbles. We're going to randomly select 3, and when you see this word different, that is how you know that you are doing sampling without replacement. Okay, so the first thing we're going to want to do is list the sample space. So every time we draw a marble, we're going to keep that marble out, but we will be selecting a red marble or a blue marble each time. So let's consider what happens one marble at a time. So it's possible that the first marble we select is red, the second marble we select is red, and the third marble we select is red. Notice that for each choice, though, we have 2 options, blue or red. So 2 options times 2 options times 2 options is 8 options. So we will end up with 8 outcomes in our sample space. So we could have all red, which means there are no blue marbles, or we could have 2 reds, which means we have exactly 1 blue marble. So let's suppose that the first marble is the blue one and the second 2 are red. But we could also have the first one be red, the second one be blue, and the third one be red. Or perhaps the first 2 are red and the last marble is blue. These are all the ways, just 3 of them, to have exactly 1 blue marble. What about 2 blue marbles? Well, we could have the first 2 be blue and the third one be red. We could have the first one be blue, the second one red, and the third one blue. Or we could have the second one blue, the first one red, the second one blue, and the third one blue. And these are the 3 ways to get exactly 2 blue marbles. And then, of course, they could all be blue, in which case we would have 3 blue marbles. So this here is the sample space, and it consists of 8 outcomes because every time you select a marble, there are 2 possibilities. It is either red or blue, and since we're doing this 3 times, we get 2 times 2 times 2, so we will end up with 8 possible outcomes. Now let's find the probabilities of each outcome. So we know that there are 12 red marbles, but a total of 32 marbles because we also have 20 blue marbles. So the probability the first marble is red is 12 out of the 32. And then we select another marble, assuming we have kept the first red marble out, so that there are now only 11 red marbles out of 31 remaining marbles. And then when we select the third marble, there are only 10 red marbles out of 30 remaining marbles. So when I hit enter, you can see I get a probability of 0.04435. Note that when I'm doing a computation in Excel, I have to start with an equal sign. We use the / for division, and we use the asterisk for multiplication. All right. So now let's look at what happens when we look at selecting exactly 1 blue marble. So let's just say, okay, the first marble is the blue marble, and there are 20 out of 32 blue marbles. And then we keep that marble out, but we select a red marble. There are still 12 red marbles, but now there are only 31 marbles remaining. And then we select another red marble, and now there are 11 red marbles out of a total of 30 marbles remaining. So we get a probability of 0.08871. Let's compute now the probability that the second marble is blue and the other two are red. So equals the probability the first marble is red is 12 out of 32, and the probability that the second marble is blue is 20 out of 31 remaining marbles, and the probability that the last one is red is 11 out of 30 remaining marbles. So we get a probability again of 0.08871. So notice that when there is exactly one blue marble and the other two are red, you have the exact same probability. So we know then that selecting two reds and then the last one being a blue marble will have the exact same probability. So let's see. First one red, 12 out of 32, and second one red, 11 out of 31, and finally last one blue is 20 out of the 30 remaining marbles, and again we get the 0.08871. Let's now move on to getting exactly two blue marbles. So the first blue marble, 20 out of 32, and the second one, 19 out of 31. And the third one is red, so there are 12 reds out of the remaining 30, and that gives us 0.15323. So we know the next two will also be 0.15323, but let's go through them anyways just for some practice. So the first one is 20 out of 32 because it's blue, times, now it's red, so there are 12 red out of 31 remaining marbles, and the last one blue, there are 19 blue marbles left out of the remaining 30 marbles, and there is the 0.15323. Okay, we have one more with two blue marbles, and this one is when the first one is red and the last two blue. So the probability the first one is red is 12 out of 32, and the second one blue is the 20 out of 31, and the third one blue is now 19 out of 30 remaining blue marbles. Again, there's the 0.15323. Finally, we have the case where all three of the marbles are blue. So first one, probability 20 out of 32, and 19 blue left out of 31. And finally 18 blue marbles left out of the remaining 30, and we get 0.22984. Now, since this is the entire sample space, whenever we select three marbles from this particular jar, one of these outcomes has to occur. So that means this here represents the probabilities of everything that can possibly happen. One of these events has to happen, so it is certain that one of these events will happen, which means that the sum of these probabilities should equal 1. So we know then that we have found all the possible outcomes and have correctly computed the probabilities for each of those outcomes. So now we're going to construct the probability distribution table where we let x be the number of blue marbles. So I am going to go over here and I will label x for my first column, p of x in my second column. X represents the number of blue marbles, so as in the first case of red, 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 we know that it's possible to have 0 blue marbles, and the probability of that happening is the 0.04435. Next, we can have exactly one blue marble, and we know that there are three ways for that to happen. Blue, red, red, plus red, blue, red, plus red, red, blue. They all happen to be the same probability, so it's the same thing as doing 3 times 0.08871 to give us the 0.26613. Next, how many ways to get exactly 2 blue marbles? Well, we saw that the first 2 could be blue, plus first and last could be blue, plus last 2 of them blue. Here are the 3 ways to get exactly 2 blue marbles, so the sum of those probabilities is a probability of getting exactly 2 blue marbles. Notice that now is 0.45968. Finally, the last thing that can happen is that all 3 marbles are blue. There's only one way for that to happen. They're all blue. And so there is our final probability of 0.22984. Notice that this table here contains all the probabilities that we looked at here. So its sum should also be 1. And we have confirmed that. So now here is our table for selecting 3 different marbles, with X being the number of blue marbles. Finally, we want to construct the histogram and give its shape. So let us go back here, and to select the histogram, or to make a histogram, what you want to do is only highlight what will end up being on the y-axis. So histograms will always have X on the x-axis and P of X on the y-axis. So I highlight only the P of X column, and I go to Insert, and I click on the icon of a histogram, and you want to do either the 2D clustered column graph, what the Excel calls, or a 3D column. I like the 3D just because I think it looks cool. And so here is the graph, or the histogram, partially completed for selecting 3 marbles and the number of marbles that are blue. Now in a histogram, we need to have the bars closed. And in our case, we also need to have these labeled from 0 to 3 rather than 1 to 4. So the first thing to do, close the bars. Now, when I do a 3D, I have a couple of ways that this can be done that will look nice. Notice up here under Chart Tools, there's Design. Now, this last one here, Style 12, you might have noticed how it changed a little by adding some shading here to give it a contour. So now when I go to Quick Layout and I go down here to Layout number 8, I get the bars closed, and we can see each of the individual bars here on the histogram. However, if you had instead done a 2D histogram, things would look a little different. Let me first finish with this 3D one, and then I can show you what you can do with the 2D histogram. So we're almost done here with the 3D histogram. But let me label our titles here. So this is X. Notice you don't see anything here because I only clicked on it once. But up here at the input bar, you see where X has been input. And when I hit enter, it now goes down here. Vertical axis title, P of X. Again, you can see it up here in the top, and now when I hit enter, it goes here. Of course, if you double click into these boxes for the titles, you would see it type right in there. And now we need to change the horizontal axis labels to 0 through 3. So back here in our Chart Tools, go to Design, and now move to the right where you see Select Data. And over here where it says Horizontal Axis Labels, Click Edit, and now all we have to do is highlight the values in the X column. Notice as soon as I highlight them, you can see them over here on your histogram. They won't be permanent though until you click OK and another OK, and now we have a nice properly labeled histogram. This histogram is fairly symmetric. It is almost bell-shaped, but it does have this little extra bar here that's lower than the others that kind of gives it what we call a tail. So this is basically a left skewed histogram. Although it is very close to symmetric. Let me show you then what happens when we do a 2D histogram and how you can get the bars to be individual so you can see them better. So let me slide this histogram aside and begin again. So I have to click into an empty cell and then re-highlight the P of X to start a fresh histogram. Insert histogram icon. This time we click the 2D clustered column graph to get this here. And now if I just go directly to my quick layout number 8, notice that when it closes you can't see the individual bars. It's just a big wall. So if you want to get I would like you to get the individual bars. So one way you could do this is to right click on that histogram and go to outline. Now notice outline currently is in the same color as the bar, that's why you can't see it. So if you click and pick a contrasting color such as black or even white, okay, you can see then the individual bars on your histogram, and now this looks like a legitimate histogram. Let's give it the axes titles. It is a left skewed histogram, and change the labels again. So remember, we go to design and this time to select data, edit, highlight our X values, okay, okay, and then here is another perfectly nice histogram, but now it's just 2 dimensions. So those are the probability, or that is the probability histogram. I showed you both a 2D and a 3D, kind of in my favorite formats. Okay, now it's ready to find the descriptives here, what we call the parameters that describe this. Now, the first parameter you're asked for is the mean. Okay, now the mean is the weighted average. That means each of these possible X values is weighted by its corresponding probability. So if you were looking, say, at a 3D histogram, that's the same thing as finding a balance point. Okay, the mean is like a balance point. If you look here, we can see 2 has the greatest weight, but we got this little tail over here kind of pulling things over. So we should have a mean that is close to 2, but just perhaps slightly less than 2. So to find the mean, we want a weighted average, which in Excel is a sum product. Now if I put the equals in here first and I start typing sum product, notice the formula will come up. I can double click on it. It has the open parenthesis for me already. And what a sum product does is it takes 2 columns. Here we have our X column, comma. Notice how it entered the column from L4 to L7. The colon means include everything in between. Then I have a comma for the next column, which is the P of X column. Don't forget to close parenthesis. And what this then does, having 2 columns, the sum product is first going to find the products of the corresponding row values, and then it's going to take the sum of the results. Hence, the sum of the products of whatever's in this first column, x, and the second column, p of x. Hit enter, 1.875. All right, we said a little bit less than 2. That is definitely a little bit less than 2. But since our outcomes, right, the possible values of the random variable have to be integers. They have to be 0, 1, 2, or 3, like we have here and here. So we don't want to have too many decimals. What we do when we have discrete data, which means whole number random variable values, we are going to round our parameters. So let me remind you that these are called parameters. We are going to round our parameters to 1 decimal place. I can do that by going up to the home menu, and then over here in the number box we're going to decrease our decimals until we only have 1, so the mean is 1.9. And I'll go ahead and write mean next to this. Next, we want a measure of the spread of the data. All right, how much variation we have, how much deviation is going on in the output. And so we compute something called the variance. And now the variance will also be a sum product. But whereas the mean, let me show you, whereas the mean was a sum product of the x and the p of x columns, we are going to now have to create a new column called x minus mean quantity squared. So notice what happens here. We are finding the difference between each x value and the mean. All right, so we are finding how far apart from the mean. So the mean's what, about here? Here's 1. We want to know what is that distance there. Then we want to know what's the difference between the 0 and 1, between the 2 and the 1.9, I mean, 3 and the 1.9. So we want, basically, we're looking at the squared difference of the average distance from the mean. Remember, we square it to make it positive. So I need to find these squared differences. So we write a formula, click on the x, minus, click on the mean. When I copy this formula, I do not want the mean to change. It's always going to be the value in L13. So if you do an F4, and on my computer I have to hit Control F4. Oh, no, I don't. Okay, F4. There we go. Notice then I get these $2 signs. So what that does is it basically says keep L and keep 13 constant. Close parentheses, raised to the second power. So now when I copy this formula, so I point my cursor to the bottom right corner, left click and drag, and then we see that the L value changes, or I should say the X value changes. It goes from L4, uh-oh, you don't like to do that. Let's get rid of that. It goes from L4, enter, to L7, but the L13 always stayed the same. So now we're ready to find the variance using the sum product command. And this time, instead of the x column, we want the x minus mean column, comma, but it is still weighted with the probabilities. Close your parenthesis, and here is our variance. All right, again, we want to take this down to 1 decimal place, so that rounds to 0.7. And to remind you of what we did a sum product, but this time it was for the x minus mean squared column, and the probability column. Okay, so there's our variance. Now, the problem with the variance is we squared it, so it's in squared units. Okay, so to get rid of squared units, you must square root. So what we're going to do then is compute something called the standard deviation, which I normally abbreviate just as SD. So I'll put SD here. And the standard deviation is simply the square root of the variance. So formula for square root is SQRT. Click on the variance, close parenthesis, enter 0.8 because we need to round this down to 1 decimal place. And now we see that we are finished. We are finished with our analysis for this problem. We have found the sample space, the corresponding probabilities. We then created a table where we had all the possible values of the random variable, where x represented the number of blue marbles in the 3 selected. The corresponding probabilities, which we found by simply adding up the ones that satisfied. So like here, exactly 1 blue marble were these 3, so we added all 3 of those up to find its probability. Probability of exactly 2 marbles involved these 3 outcomes, so we added all those up to get the probability of exactly 2. Only one way to get exactly 3 blue marbles, only one way to get no blue marbles. Then the parameters, which are the descriptive values, right? We can just call them descriptive values, right? We found the mean, the variance, and the standard deviation. The mean is a measure of the middle. So when you think of balance point, it's like middle. We define the middle as basically the balance point. And we found that using a sum product, which is basically we're finding the weighted mean of the x's, and they're weighted by their probabilities. For the variance, we found also a weighted mean, but now it was a weighted mean of the squared differences from the mean, weighted average of the squared differences from the mean, but still weighted by the probability. And then, since that was in squared units, we had to unsquare it to get the standard deviation. All right. And then we have to make sure that each of these parameters is rounded only to 1 decimal place, because the original values of the random variable are discrete, which means they are integers or whole numbers. So we only can go at most 1 decimal beyond the values of our random variables. So we go to 1 decimal. Don't forget, we also made histogram. And so we see on this histogram here, okay, that we had a slightly left skewed, slightly left skewed histogram, because basically this tail here pulls it, the mean, towards the left of the highest value. And that's why we knew we would get something here which was, let's see, something in here, let me just do this, something in here which is just less than the 2, but being dragged to the left because of this tail here. Alright, so that ends this little presentation on sampling without replacement. Thanks for watching.